You know what I mean? So we're not far off the epicentre of the universe, are we? You know, we're in Alford, right? You wouldn't think. Like, you look at the product and the detail of all the products, you would never think that that comes out of deepest darkest Lincolnshire. You know what I mean? That comes out of some. Because you just can't really believe what you do. You know what I mean? There's so much. What's happening? This is just
storage.
Storage.
Yeah. So they're what's called VLMs. So vertical lift modules. So if you look down here,
this is to get away from having people in fork trucks going around and picking stuff out.
Yes. So yeah, basically they are the fork truck. So these trays go up and down, and those trays are stored in the back of the machine, front of the machine. So the tray, it'll go. There's a carriage. It'll go and pick a tray out, pull it down, bring it down.
So just explain how that works. So an order comes in.
Yep.
Right.
Yep.
I want a tail tidy for a Yamaha R1. Right. Go on. How's that work?
Okay. So you place the order on the website.
Yeah.
So the order comes in on the website. It'll then when it's paid, then it gets turned into an order that actually has to be picked. But that tail tidy might be made of several components.
Okay.
We don't necessarily store it as one component, because there might be common bits to other bits.
Okay, right.
So then the software will then know that it's stored in several places, and then it will tell the machine to actually go, whichever machine it might be in, it might be one down there on the right-hand side, it will bring that tray down, and it's got a light on here, and the whole machine will light up to say it's here, and then the red light on there will show you where the part is, and then you just pick it out. But then, secondly to that, to make sure you don't pick the wrong part, it's barcoded as well. So it'll scan the barcode, it'll go beep and say it's right, and then we have other barcodes over here to verify it. So basically, the customer never gets the wrong part.
Who makes these machines then?
Modula in Italy.
Right.
So
all this is about is just an efficient use of space.
Yeah, absolutely.
Right.
Yeah.
And man hours.
And man hours. Yeah.
That just the whole your storage machines, right? And then you're using them storage machines for half-made bits in there, right? Just yeah. I don't want your electric bill. You have. I see. I'm just looking. You have solar panels. You have got solar panels.
So this is for your final packaging. Well,
all right, mate. How you getting on?
Until you get to the end. These are injection moulded bits, so we get those made. They're made in Swindon.
Go on. What's that for?
That's to hold the license plate light on a CB650. Actually, it's common now, so it shares more than one.
Oh, so you sub that bit out?
Yeah, we sub that bit out.
Look at the quality there, though.
Yeah, so we designed that, just sub it out. It might have the part number on there and stuff.
Yeah. It's a part number on it. Yeah. Riv nuts in the back.
Yeah, that's it. Yeah.
Beautiful.
So that's part of Dan's crash protection. Their TPU washer or polyurethane. TPU is polyurethane.
Go on. What's TPU stand for?
I know the PU is polyurethane, but I don't know what the T bit is. Oh God, you've got me on that.
No, you're right.
So, and then all these things we do, like clever things.
What do you reckon that is?
That's a Garmin. No, that's a TomTom sat-nav mount. That's like we do, like that's injection moulded, but we tag them together. So rather than you having.
Are you doing that?
No, that's done in Swindon. So that's a rubber, but they're for cap head bolts. So you just put the caps. They're for sat-nav.
That's beautiful.
Yeah. So what you do, rather than
see him.
So for
just for aesthetics, just to put over the cap head bolt, just to make it.
But now
it's got your logo in it as well.
Yeah. But what we do, if they say an old way would be just to buy that bit in, that bit in, that bit in, that bit in, and you'd have to pick 2 of those and 2 of those. But we can get them injection moulded as a group, so you just chuck one into the packet. It makes it loads quicker.
Yeah.
So when you're packing 20,000 of those.
Efficient use of time, that, isn't it?
Exactly. We do.
That goes in there.
Yeah, that goes in there. Yeah. That's a Z900 Kawasaki Z900 RS tail tidy. That KTM 1290, 1390 chain lubricator. So what it is that you clip that onto your chain, and there's
put your spout in there.
There's a little tube that hangs off it. It's not quite.
I didn't even know you made one of them.
Yeah. And then there's a blade jet in there, and it squirts it evenly around your chain, but doesn't squirt.
You've seen that? No one knows. I've known your stuff for years. I don't know about that. You make a chain oiler, right?
Yeah,
just explain how that works.
So what happens is
you stick that over your chain. I stick my spout from my chain lube in there.
There's a little silicone pipe that hangs off there. Yeah.
Go on.
So then what you do, you put your can on the floor.
Yeah.
You hold that bit. So no, the can holds the pipe, which holds that bit.
Yeah.
So you've got one hand free. So what you do, you squirt with your hand and spin your back wheel, and then it evenly coats your chain without going everywhere. But here, these are all our. We're having new power put in, but these are all our 3D printers, but they're obviously off the shelf at the moment, and there are new ones there. So that's
old 3D printers, new 3D printers.
yeah, they're FDX. So that's what you've got. Have you got a Mark Forge, haven't you?
Yes.
Yeah. So these are the bamboo equivalent of that. I know they're probably not quite glamorous or whatever.
Right.
But for us, they do the trick. They print the TPU. So you know, you picked up that chain lubricator thing.
Yes.
That's 3D printed. Exactly. So,
You thought of all this, hadn't you?
we're sad. This is a SLS. Have you heard of SLS?
I've heard of SLS, I don't know what it means.
Right,
I've heard that, go on.
Selective laser sintering.
Yeah.
And what it basically means is that that's a recoat roll. This is live pictures, by the way. It's not making it up.
Are you getting this? Are you getting these words?
So what it's doing, it'll do a recoat now. So that's a recoat. So that's
This is live.
A fresh layer of powder just gone.
How many microns at a time, or what?
110 microns.
Oh, fair amount then.
0.11 millimetres.
Yeah, well that's a fair amount every time.
Yeah, and then what it's doing, it'll laser the outline of the part, so you'll see it go in. So it's just on the outside. Now it's doing the fusing the centre of the part, the body of the part together. So.
And what is this? What are you making here?
That's MTO7 tail tiders combined with.
Which is what we've just had hold of there.
That was a R9. This is a brand new.
I'm getting confused.
Yeah,
I'm getting
so
confused.
It's that. So you can't machine that. No way on this planet. But
how many setups would you have to be able to machine that?
You can't actually do it because I think it's impossible because you can't get into like the certain angles.
So the only way to make that is to print it. That would be, if you had a billet, that would be impossible to machine.
Yeah. So if you were doing it out of billet, you compromise the design to actually achieve what you want to do.
Yeah.
As it wouldn't be as neat. You know, you wouldn't get these back cuts and things like that. But with 3D printing, you know yourself, you can just design the impossible, can't you? So it's got threads printed into it and all sorts.
Oh, you don't put an insert in. That's threads printed in that you can use.
Yeah, when it's like that.
Well, I thought you sort of be pioneers of 3D printing. I remember, how long ago was it? I did the Wall of Death. You made me all the back end of my bike, and you 3D printed that, and that you sort of, like, no one had heard of 3D printing then, had they? This was what, over 10 years ago that was? Be 10 years ago. And you're not using the 3D printing for prototyping stuff, you're using it as a finished product. The Tatey man out our way are nearly running out of water for the irrigation.
Is he?
What are you doing? Are you lasering there?
No, it's punching. So it's just piercing through the metal. So the head's gone down, you see? So basically the head's gone down to clamp the sheet in place, roughly, within about, what, 3 or 4 mil?
Go on.
And then what happens is, the punch comes down, it happens in so quick you can't actually see it happen, but then there's a stripper plate comes down, and then the punch goes through the stripper plate, through the metal, through the die, and then the slug comes out.
This is your raggas, and you're putting... Oh, so that doesn't come off an extrusion with that on, you're putting all of those holes in.
Yeah, it starts off as a plain sheet, so every one of those is pierced in.
Is all of that done in one sitting? All of those holes and the perimeter and these holes all done in one go?
Yeah, yeah.
Go on, what are you doing here?
So this is, you'll know all about...
look in here.
Oh, so this is 5-axis simultaneous. So that's 5-axis simultaneous. Do you want to know the specs on the machine?
Yeah, go on.
Right, so it's 24,000 spindle on it.
Yeah.
25 tools.
Yeah.
Chip to chip, 1.5 seconds.
Yeah.
I think the bed can hold 300 kilos, but we only hold about 1 kilo at a time or something like that. So it's massively over the top of that. What else has it got? It's got CCS.
Through coolant.
Yeah, through coolant. So all the tools have jets on them. It's about, I can't remember how many bar pressure it is. It's like 40 bar pressure, I think, for the coolant. It's the spec of the machine is like mega spec. It's you don't get much higher really. The 24,000 spindle on it is really good though. That's one of its biggest strengths. To enable this to run 24 hours a day, you need this on the side of it. So it's got, this is System 3R automation.
Go on.
So you see all these? All those?
Yeah.
They're all they're...
These are finished tail tiders.
Yeah, they are.
Off to the first op.
Yeah, so in this cabinet, I think there's 126 stations. There'll be op 1 and op 2 in here.
Yeah.
So they look like they're finished op 1s, they do. And then you flick it over and then turn it into an op 2, but you have to do that manually. So at every 24 hours, roughly every 24 hours, half of this cabinet spits out finished parts. So they come in the morning and just change over all the stations. So they'll put fresh stock in and flick op 1s to op 2s. Does that make sense?
Yeah.
Yeah. It's really good and it takes the pressure off the operator in some respect. But,
So you just need one man here or girl to swap over the stock, and then that keeps that machine going for 24 hours.
yeah. So, but it gets even better out the back here. So the scrap goes on a conveyor down the centre of the machine. It conveyors it that way out the back. So
Dan was telling me about this.
This is super sad. So I'll give you all the specs.
This is just
right?
for crushing the swaff up, so it's more efficient to weigh in at the scrappers.
Yeah, right. So it has two things, right? Or several things. So it goes into, it's a rough briquette. So it goes into there. That's the ram that crushes it down there. It goes down like that and crushes it. Comes out as briquettes. So the specs are, if you can get it under 3% moisture content, it is worth more money to the scrap man.
Oh, is that right? Is that the reason? Right,
yeah, so we can
right.
sell it for more money. But then not only that, we can compress it at about 10-to-1 ratio.
Yeah.
So you can squeeze all the moisture out. We reclaim the coolant, we get more money for the scrap, and we don't have scrap bins everywhere pissing fluid out. Dead easy. So you'll see there's no fluid on the floor. It's just dry. So, yeah, and so it's weird, isn't it?
Who else goes to that extent?
I know.
Who else?
I don't know, but actually not many people. They came from the woodworking world, by the way, the rough do, but we've got better ones now anyway.
You know what I mean? So we're not far off the epicentre of the universe, are we? You know, we're in Alford, right? But you wouldn't think. Like, you look at the product and the detail of all the products, you would never think that comes out of deepest, darkest Lincolnshire. More machines, more stuff getting turned from first op to second op.
Yeah,
or finished second op. Yeah.
Here, these are ace. Right. These are sort of like
Tail tidy.
Yeah, the parts are, yeah. But these are like big routing machines.
Vacuum bed.
Vacuum bed, that's the key to it. But the way they do it is really cool. It uses sacrificial card. Because you can't, if we put that straight onto metal, A, you won't get a very good suction on it, and B, you'd effectively machine away your good metal bed. You don't want that. So what you do, there's on here, look. You see, so you use that card allows air to pass through it, so you can suck down the card, that to the card to the bed.
Right. So that's what is that a specific porous card then?
Yeah. So absolutely.
So that's the sacrificial bit. So you're not going into a bed.
So look, you can just see it's gone into there.
That needs to be accurate, that, doesn't it?
Yeah. This is not for dispatch for customers. This is for us to store bits in on the shop floor to keep it nice and clean.
You've obviously had to do that 5-axis.
Yeah, that's right. Yeah.
Why do that? Why not injection moulding?
Because you can't, in some respects you can't. You know that first machine we saw, the DMG?
Yeah.
They're made on the DMG.
Are they?
Yeah.
Two settings.
Yeah,
two
exactly,
fittings.
yeah.
So all of this has been done, so 2 sittings that's been done in, but all of this radius on there, that's all been done in the, right.
Yeah.
Okay. What a setup.
All in Lincolnshire.
You wouldn't think, would you? I know this is the sort of #1 thing, isn't it? Like, I say to Matt, obviously we're not quite in Grimsby, are we? Right? I'm Grimsby's #1 fan. You are sort of Grimsby. Yeah, you are a Conhead. You are. Yeah. Okay, right. Okay. Yeah, I don't. You wouldn't. You would just think, well, that comes obviously, made in America or made in Taiwan or China. But you wouldn't think it's not come out of China, because there is some amazing things come out of China. You know what I mean? I've seen some of the amazing things come out of that place, right? But to this level of detail is another level, man.
So 6-axis bending. We'll take a flat part like that, flat part, and it turns into that part. So
all of those fold in one sitting.
Yeah.
You just have a male and female.
So that's why it's got multiple stations.
Right. So this was sort of the bedrock to Evotech. Yes. The sheet metal working, all of the folding and the.
Yeah.
Right.
So you know when you get, it's like origami, but you know when you get on the back of your cornflake packets and all that.
Yeah.
When he was a kid, he used
Yeah,
to
hey, mate.
get this shit and he used to fold them up. Well, this is like just a big boy's version of that, isn't it? But that's off a Gladius tail tidy, and that's also the lock-in place there. That's sat-nav mount off that new Axe Diablo over there. You know a bit about powder coating, don't you? You know
A bit, yeah.
electrostatic.
Yeah.
So basically, this red rail here is earthed out.
Yeah.
You charge the paint particles positively,
Yes.
and they're attracted to the negative.
Yeah.
In theory, you should get a nice even coating. It doesn't quite work like that. You've got to have a skilled operator to do it.
Right.
But basically, that's it. So here, normally, all the flight bars are empty. So we would fill up all these flight bars, as many as we can, and then it travels this way round. So it goes round here. This is pre-treatment.
Go on.
So it's a 3-stage pre-treatment. So the first one is like a detergent that washes the parts and gets the debris off.
Yes, yes.
I think the next stage is like, I think that might be iron phosphate pre-treatment. Right. And then you go into a mineral wash that cleans it. It's like pure water.
Yeah.
It just cleans the parts. There's no minerals left on the part whatsoever.
Right.
Then what happens? It comes out of here. We're going to go right there. So it'll go through here. It'll drip dry onto those trays there.
Yeah.
Then it goes into a dry off oven.
Yeah.
So all the parts are still on, dry off oven. It only goes to about 90 degrees, something like that. It's not very hot.
Hot enough. Yeah.
Just to dry them off. Probably
Yeah.
spend about 5-6 minutes in there.
Yeah.
And it'll go down the line across there, all the way across there, and that's your painting booth. So on demand, he'll press that button and then it'll fire another bar through, and then he'll powder coat it. And there's a manual rotation.
This is right. Okay, this is manually done.
Yeah. So just
So what temperature is it when it's coming through here then? So it's got to 90
just-
degrees through there.
Yeah. Just
Right.
at this point, just atmospheric.
Okay, okay, okay.
Ambient temperature.
Yeah.
The parts have cooled down. There's no temp heat in them.
Yeah.
And then what they do, when he's finished coating them, they queue up in batches of 6s, and then when 6 is ready to go in, it goes into that oven.
Yeah.
That takes it to about 200 degrees. It'll stay in there for about 10 minutes.
Yeah.
And then it'll come back around.
10 minutes at 200 degrees.
Yeah. Then it'll come out the end of the oven automatically, round this line, and go back to the beginning, and then you unhang them and start it all again.
Yeah, British engineering, I know. British, you know what I mean? Like, what else do you hear British engineering? Like Rolls-Royce, JCB, you know what I mean? We're not, you know what I mean? Land Rover, Hope. It's not, is it? We're not swimming in them. You know what I mean? And Evotech are at the, yeah. So go on.
Yeah,
What's the score here? What's happening?
So this twin spindle, twin turret lathe. So as you can see,
Twin spindle, twin turret.
so we've got a main spindle which
Have a look in here, boy. Have a look in here.
feeds the bar from the other end.
So we can machine on either chuck.
So what it does is it feeds the bar in from the bar feed at that end.
Yeah.
Feeding it through. We've got 2 turrets there. We can work on both turrets at the same time. So we can.
Oh, you can have 2 jobs going. You've got 2.
Yeah. So what we can do is we can actually pinch turn, balance turn. So we can actually turn on both sides. So say you're taking like a 3mm depth of cut on your roughing,
Yeah.
you can actually do 6mm because you do 3mm both sides.
Bloody
Yeah, so
hell,
you balance
right.
it, and then it makes it even better because
Right.
so normally you've got a long component, as you'll know. You
Yeah.
have to have like a tailstock in.
Yeah.
If you've got a turning tool on both
Both sides, you
you're
don't need a
balancing it,
tailstock.
so you don't need it so much. Yeah, so you can actually balance turn it. You can balance.
Well, give us an example on a part that you'd need to
Well,
use that
everything,
operation.
we're always using it. So for everything we do, we use it because it just optimises the time. You know, we're just roughing twice the depth of a normal lathe with 1 turret.
Yeah.
You know, so
Yeah,
we do
yeah.
everything we turn it like that.
And is this a self-operating machine then?
Yeah, once we've got it going, the operator sets the job up, presses you go, and then it'll just keep running and running and running.
Keep chucking the bar in.
Just keep chucking it through. So what it does is we'll turn the component on the front spindle, we'll bring the sub spindle across, grabs it, parts it off, passes over to the sub spindle, and then starts the machine on that side. So it can all be going. So what you do is you optimise your turrets, so you try and get as much time on the front and the back, so it also unloads the back with a parts catcher from there, pull them out there, grab it while the front's still going. So you've got no downtime. So the whole process is constantly constantly working.
Can we see this work?
Well, we've got another one, small version there,
Is
that's
that right?
working. So if you come over this way.
I'll take my brew with me. I don't want to lose my brew. Go on, how long you worked here, boy? You've been here a bit, haven't you?
25 years.
25, I thought you'd been here a bit.
So this is doing a bar end collet at the moment.
Oh, so that's for like brake protector?
Yeah, so it's actually for a handguard kit, that one. So
Okay.
it's the collet that goes in the bar end, and then we'll have like a wedge that goes in that side. So you bolt through from there, the wedge pulls up against it, and it's just like a collet. You can see the slots in there, look. You see the 1/2 mil slots in there.
Yeah, yeah, yeah.
So we've got a big BMW collet to do for a rear spindle.
Yeah.
Yeah. It's out of that bar down there, which is 66 mil bar. It's got 3 mil slots in either side. It's got about 8 slots, so we'll actually come and we'll pinch mill it from either side at the same time. So we'll balance turn it, pinch mill it. You know, you're reducing all your cycle time then. And it's,
Bloody
so
hell.
if you can,
Where's that getting etched on?
it's
Not in
rolled
here.
on. Yeah, yeah. Oh yeah, that's.
Is that getting done in this operation here?
So yeah, you've got bar going in that end. It's coming through,
And it's coming out like that?
coming out like that.
So you're doing that? You see the lettering? All done in that one operation?
all done in that one operation.
Coming
yeah.
in there as bar, coming out as that.
Coming
No
in
other
bar.
operation.
That's it.
How are you machining that? That's
So
square.
that's on the back end. So it's machining that on the sub spindle while the front's still going. So
See
what
that?
we'll do, we'll
See that
just.
square in there?
This is sliding head lathe. So concept with a sliding head is the other lathe that we've just seen there. You have your bar stuck out and your tools move to it, right?
Yeah.
Sliding head lathe is the opposite. You actually have your bar, it feeds out, so it actually pushes it out while it's rotating.
Yes, yes,
Right,
yes.
so your tools are held. There's a bank of tools there, you could just about see them.
Yeah.
Yeah, through the oil. So they're in a fixed position. So the beauty of that is you've always got a constant distance between where it's supported and where the tool is.
Yes.
So you don't get your vibration that you would if you imagine you're machining 6 inches away from the collet.
Yep.
You know,
Amount of
you know,
distortion
the
you'll
amount-
get.
Yeah, and it flexes. You don't get any of that because, as you can see, the bolt, the material's coming out now. You see the bolt coming through. So that's actually machining it as it's coming out. You just see it start appearing.
Hell,
Yeah.
yeah.
So
So
what-
this is doing 2 jobs at the same time then?
Yeah. So we've got twin, same
See
as
that?
that.
Doing 2 jobs at the same
Where
time.
we've got a main spindle and a sub
Are
spindle.
you cutting threads or they're rolling them on?
Roll thread's just gone on there with that arm at the back there.
Yeah.
So it rolled it on. And then we've also got the. This is a new for last year. It's a long parts adapter, so we can make you a bolt that's 450 mil long now. And we can actually rather than feed it this way, we'll actually feed it out the back of the spindle. So, you know, because of the way that the sliders work, you can actually, in theory, you can carry on turning as long as you want. So if this wasn't all in the way, we could actually.
you could have a bolt.
You could have a bolt 3 meters long if we wanted to. If you could do it, but we've got the ability, because we don't do it, obviously we're not geared up for that, but we've got the ability to turn up to a 500 mil bolt. And we've done one for a race team up to about 350 mil long. I think
Yeah,
it
go
was.
through a swinging arm.
Yeah.
Oh, well, Dan was showing me
Yeah.
that.
And then, on the other side, this one's just a slightly newer last year. This is a Type 10, the other one's Type 8. The new one's got a programmable B-axis on the back end there, so you can literally program like 5-axis stuff. So, you know, like little impellers in turbos. Yeah, you can actually machine those on here if it's small enough. So it's you see how that head.
So still the tool stationary,
Yes.
and it's moving.
Yeah, so it's a station that drops down there, the B-axis they call it, similar to that, but it's a programmable one, so it'll actually program and it swings through about 120
Also, it
degrees.
becomes like a 5-axis milling machine.
the
that.
5-axis milling machine. So then you've got your C-axis that
Holy
controls
That's what I was
with
thinking.
that.
It was still turning the workpiece on a stationary tool.
No, fully driven tools then. So
Oh, fully driven tool. That's what you call it, right?
yeah.
Okay.
So this is a driven tool on the front. Got driven tools on there. So the engraving that you saw on the bolts was from the engraving tool there. So we're actually engraving, and what it does, it manipulates it with the C-axis. So the C-axis on the spindle will turn as you're going. So as it's putting on, because that's a fixed head that way, it can come up and down with its X-axis that way.
Yeah.
But then to make it go that way, it has to feed the bar out. So it's sort of like doing all
So
this.
that's fully simultaneous then.
Yeah. What
That'll be the trickiest machine in this place then, wouldn't
Oh
it?
yeah, it'd be a cracking machine.
When's that coming?
Monday.
50 quid's not buying that.
No, you need a few pound notes for that. But yeah, this one's got the advantage from that one to this one. It's got an extra 4 tools on the back there.
Yeah,
And this
yeah.
head does. So this is what we call a platen, and it does slide up and down. So then all of a sudden we can put milling tools in this station. So like for instance, like a caliper bolt. If you want to unlock wire holes in the side
Yeah.
of it, all of a sudden we can actually put the lock wire holes in the side of it. We can actually mill on there. We can do the engraving on this end as well. And like you can see, we've got, that's the probe that we've got in this end for checking stuff. And then we've got more tools, so we can actually put sister tooling in this. So we've got sister tool in there, so we can run longer lights out.
No, I don't know what that means.
So what that means is that when the tool's knackered, because the quickest tool to run out on these is the parting off tool.
Yeah. Well, they 3 mil or something.
Yeah, 3 mil parting off tool. So we know that we get about, I don't know, about 5 hours tool life out of the parting off tool. But to obviously get us another 5 hours, we put 2 tools in there. So
Will
we
it
call
automatically change?
So what it does, it gets to that time and then it swaps over to the next one.
Oh, it doesn't have to foot before it changes then? Or
No. No, so it literally
just knows,
we do it
get
on
to
time.
X amount of time,
We've run
swap
so
over.
many of them that we know at that certain time that after, well, what we do is,
you know what to do.
obviously if it goes for like 6 hours, we'll do it at like 5 hours and say, right, go 5 hours, then change tool, and then it goes from tool number 1, tool number 2, and we do the same thing on the other tools. So we get the most out of it. We're constantly trying to get efficiency.
That's what this place is all about, isn't it?
Yeah.
Mate, mate.
Yeah, well, it's good
Mate,
stuff,
this
isn't it?
is the tits, mate.
It's quality,
No,
isn't it?
I'm just blown away. Dan's been raving on to me about this sliding end machine, and I didn't really understand. And yeah, now I've seen one work.
That's the sort of Swarf you get, look. That's
Yeah,
from
that's
LFE.
brilliant.
So you don't get that from, if you've got like a normal lathe.
Swath. That's the size of a swath. Yeah.
And that's from low frequency vibration. So it actually oscillates the spindle as it's turning. So it actually makes it chip from this low frequency vibration. And that basically, if you turn it on or off, as soon as you turn it on, you get swarf like that. You literally turn it off and you get stringy swarf like you'd normally get from a centre lathe.
Knots everything up.
Yeah.
So we,
Yeah. It's
See, you
magic.
got that? So it's a frequency, so it breaks up the chip, so you don't end up
Breaks
with
up the chip.
massive swaths
Yeah,
bunging everything up.
Low frequency vibration makes the swarf chip, and then say literally night and day, turn it on, chips all swarf, turn it off, you
Changes
get a bird
your-
nest. Cool. Just
Mate, thank you for your...
cheers, pal.
Mate, it's just
Good
some
to see you
knowledge.
again.
Watchmaking technology that I just think who would know about that? Sliding head technology. You know what I mean? It doesn't make sense how you're doing it. How can you possibly slide your workpiece through the chuck on a lathe so you don't need to put a tailstock in? Now that's just enough like the bolt making, right? Yeah, to keep in keeping with the quality of Evotech, right? You could just go to back bolts and get your bolts, your 12.9 cap heads, but it's not quite right, is it? That cap head wouldn't look quite right against your product. So the only way to do it is make your own bolts. You know what I mean? And it's just all the banning detail you put on, which there is no need for any of that, right? But you just do it because you can. Like the place has changed, hasn't it? It's just, everything, my God. Yeah, no, so I'm dead pleased I come down. Dead pleased I come down, thanks very much. No, mint, fed and watered. Got canteen and all that? Yeah, blown away. I'm blown away. What a job. So what do? You've just got to get bigger. You're going to end up taking half of Alford up. Thanks for having us, boy. Thanks for the tea. Thanks for the sarnie. Thanks for the look round, mate. It's been mint. Thank you.
Next time.
Yeah, we'll do what? What would you get me doing? Yeah, but to be honest, get me working, I can sweep the floor, but there isn't really much to sweep up, is there? Because everything, and there's everything's covered, isn't it? It's all automated. Nah, fair play. Sound job. I can keep this cup. Thank you. It's prototype, yeah. Thank you.
That's a one-off, that.
You know, go on. I just want to get the reason for. Yeah.